Hi friends, in this session we are going to discuss about CPU scheduling. CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold in waiting state due to unavailability of any resource like input, output, etc. The selection process is carried out by CPU scheduler. There are five types of CPU scheduling. They are CPU utilization, throughput, waiting time, turnaround time, and response time. First one, CPU utilization. It is the average function of time during which the processor is busy. CPU utilization may range from 0% to 100%. Second one, throughput. It is the amount of work completed in a unit of time. That is, the number of processes the system can execute in a period of time. The higher the number, the more work is done by the system. Waiting time. The average period of time a process spends waiting for the control of processor for execution. Turnaround time. It is the amount of time taken to execute a process. That is, the interval of time of submission of the process to the time of completion of the process. Last one, response time. It is the time from the submission of a request until the first response is produced. Scheduling algorithm. First one is FCFS, which means first come, first serve. It is the simplest scheduling algorithm. CPU is allocated to the process in the order of arrival. So, there are four processes P1, P2, P3, P4. Arrival time is 0, 1, 2, 3 and burst time is 3, 6, 4, 2. First, we are going to construct GANTT chart for this. So, P1 arrives at 0 and its burst time is 3. So, 0 to 3 and P2, its burst time is 6. So, add 3 with this which gives 9 and P3 4. So 9 plus 4 13 and finally P4 2. So 13 plus 2 15. Next we are going to construct waiting time. It is calculated as arrival time minus waiting time. So arrival time for P1 is 0 and arrival time of P2 is 3 minus waiting time which gives 2. For P3 7 and for P4 10. Average waiting time. It is calculated as waiting time of all process divided by number of process which gives 4.75. Turnaround time. It is calculated as burst time plus waiting time. So for P1, the burst time is 3 and waiting time is 0 which gives 3. Similarly for P2, 8, P3, 11 and P4, 12. Next one is SJF, short job first scheduling. While the CPU is free, it is assigned to the process of the ready queue that has the smallest net CPU burst. If two processes have same burst time, then it is executed in FCFS manner. SJF may be preemptive or non-preemptive. First, we are going to see about preemptive. Preemptive scheduling allows a running process to be interrupted by high priority process. So, it has four processes. Arrival time is 0, 1, 2, 3 and burst time is 8, 4, 9, 5. You are going to construct GANTT chart for this. P1 arrives first. So, it will enter into the CPU first because the arrival time is 0 but it needs CPU for long time. That is, burst time is 8. Since it is preemptive, it will forcefully push the P1 out of the CPU and the job with less burst time, which is P2 of 4, will arise next to P1, will get into the CPU. P2 arrival time is 1 and burst time is 4. So in this manner, the process with less burst time or the shortest job will execute. And in SAF preemptive, P1 is pushed out of CPU before completing its execution. Therefore, preemptive will replace one process with another before a process is fully executed. Here, P1 is replaced by P2. Next one, waiting time. It is calculated as arrival time minus waiting time. Since P1 is executed 2 times, so the waiting time will be 10 minus 1 minus 0, which gives 9. Similarly for P2, it is 0, P3, 15 and P4, 2. Average waiting time is calculated as waiting time of all process divided by number of process, which yields the result 6.5. Turnaround time is calculated as burst time plus waiting time. For P1, 17, P2, 4, P3, 24, P4, 7. And next, we are going to discuss about non-preemptive. In non-preemptive scheduling, any new process has to wait until the running process finishes its CPU cycle. So, arrival time of all the processes is 0. In non-preemptive, no process is pushed out of the CPU before it completes its execution. So, GANTT chart. P2 has smallest burst time. So, P2 will execute first, then P4, P1 and finally P3. Next, waiting time. It is calculated as arrival time minus waited time. So, P1 9, P2 0, P3 17 and P4 4. Average waiting time is calculated as waiting time of all the process divided by number of process, which yields the result 7.5. Turnaround time. It is calculated as burst time plus waiting time. For P1, it is 17, P2 4, P3 26 and P4 9. Next one, priority scheduling. Here, CPU is allocated to the highest priority of the process from the ready queue. Each process has priority number. If two processes has the same priority, then it is executed in first come first serve basis. So, instead of arrival time, here we have priority. So, there are 4 processes. Burst time is 3642 and priority is 2413. GANTT chart. So, P3 has smallest priority. So, P3 executes first. Afterwards, P1 executes, P4 and finally P2 will execute. Waiting time is calculated as arrival time minus waited time. For P1 it is 4, P2 9, P3 0, P4 7. Average waiting time. Waiting time of all the process divided by number of process, which gives 5. Turnaround time. Burst time plus waiting time. So for P1 it is 7, P2 15, P3 4 and P4 9. Next, round robin. Round robin scheduling algorithm is a preemptive algorithm. The CPU scheduler picks the first process from the ready queue, sets a timer to interrupt after time quantum dispatches the process. There are 4 processes. Arrival time is 0, 1, 2, 3 and burst time is 3, 6, 4, 2. The time quantum is 1. So, each process has the time quantum 1. So, P1 will be executed 3 times, P2 will execute it 6 times, P3 4 times and P4 2 times. Likewise, we have to construct GANTT chart. After that, we have to calculate waiting time for process P1. P1 ends at 8 to 9. So before that, it has 1 to 2, 1 time, 5 to 6, 2 times and 9 to 10, 3 times. So 9 minus 3, 6. P2 completes at 15. So between that, they are 2 to 3, 6 to 7, 10 to 11, 11 to 12, 14 to 15. So 9. Likewise, P3 completes at 13. So before that, it has 3 to 4, 7 to 8, 10 to 11, 12 to 13. So which gives 9. and P4 completes at here 8 to 9. So before that it has 4 to 5 and 8 to 9, which gives 6. Average waiting time is calculated as waiting time of all the process divided by number of process, which gives 7.5. Turnaround time, it is calculated as burst time plus waiting time. So for P1 it is 9, P2 it is 15, P3 it is 13 and P4 it is 8. Next one, multi-level queue scheduling. They are extension of priority scheduling. Here, queues are not interconnected. Each queue has their own scheduling algorithm and CPU allocates the algorithm according to the priority. The process cannot be moved from one queue to another. The last one is multi-level feedback queue scheduling. It allows a process to move between queues like this. Queues are directly connected to CPU and also interconnected with each other. So, thank you for watching my video.